So here we're going to start taking a look at evaluating and solving logarithmic equations and logarithms themselves. So a few useful log properties. These should be familiar to you at this point. Log base b of b to the x equals x. So log base b, b to the same power is that power. Log with nothing there, remember that's base 10. So that means log base 10 of 10 to the x is x. And natural log, ln, this is a log with a base of e. Remember, e is that 2.71 number. So natural log base e of e to the x should just be x. So those are a couple of special cases of this general property over here. Another one, b to the log base b of x is x. And in particular, if I have a 10 to the log base 10 of x is x. Again, with a base 10, you don't have to write it there with the log. And e to the natural log of x is just x, because natural logs are logs with a base e. So those are two special properties with a special base of 10, special base of e, of these two general properties right here. The last one is the change of base formula. So the log base b of a can be rewritten as the log of a over the log of b, or natural log of a over natural log of b, or any other base that I might want. So we can use other bases too, but generally these are used when we're trying to evaluate logs, and since our calculator has a base 10 and a base e, we'll use those two. So here's a couple of problems. Approximate the logs to 4 decimal places. So the log of 4.86. So let's go ahead and take a look at that one. So if I look at that one, I'll go ahead and bring up my calculator here and just type that in. So on this one we have the log of 4.86. So I'll go ahead and type log. So notice right here next to the 7, that's where I have log, and then 4.86. I'll put that in, and there's 0.866. Alright, so on that guy, I should get 0.866 rounded to 4 decimal places, 0.6866, okay, and then we don't round up because that's a 3. Same thing if I want to do natural log. So natural log here, okay, just type ln, it's right below log, and then 41.5. Alright, so I'll put that in, hit enter, and there's the natural log of 41.5, 3.7257 if I round that 6 up to a 7. Alright, the last one here, log base 6 of 8. So I don't have a log base 6 button or anything on this type of TI-83 or 84. So what I have to do instead is the change of base. So remember, that's going to be the log of 8 divided by the log of the base, log of 6. And you can use log or natural log. We'll look at both in a second, but that should be 1.16055. So those are all my values right there. So there's my values that come out of that. So, and again, okay, anytime that we're looking at this, we can go ahead and change this to a natural log. So if I wanted to use a natural log instead, natural log of 8 divided by natural log of 6, it should give me the same thing for that log base 6 of 8. So I do notice those are exactly the same, 1.6055. We round that 5 up to a 6 since we have a 5 next to it. So that's it as far as those are concerned. So all that is just plugging in some values to your calculator. Again, if you have a different base other than base 10 or base e with the natural log, you do have to use the change of base formula. Alright, let's go ahead and go on to the next slide here. So take the calculator off. Find the exact value of the natural log of e to the 4. I actually don't have to do too much for that. Remember, natural log of e to any power is that power, so that does give me a 4. The log of the cube root of 10, I can try the same thing. Rewrite this as a base of 10 to a power, since I have a base of 10 in my log. So something like that, I can rewrite cube root as a 1/3 power. And so the log base 10 of 10 to the 1/3 is 1/3. Alright, so we just get 1/3 for that. And then the log of 0.001, again, I want to try to rewrite that with a base of 10. So this is 10 to the negative 3, so that's 10 with the decimal place moved over uh, uh, with a negative 3 in that exponent right there. Alright, so 10 to the negative 3, we take 1 and then move the decimal place over 3 units. Alright, with this guy right here, okay, now the log base 10 of 10 to the negative 3 is negative 3, so that's it. These you could still calculate on your calculator if you like, so we'll do a couple of those. Natural log of e to the fourth, so the e button is second natural log, so that's e to the fourth, and hit enter. It does give me a 4. If I try the cube root of 10, I can do log, and if I really want a cube root, I can find it under the math menu. So number 4, there's cube root of 10, and that does give me 1/3. You can change that to a fraction if you like. So all of these will come out the same in the calculator as well. That last one there, log 0.001, does give me a negative 3. Alright, so if you can just rewrite these using the properties, or if you get stuck and you do have numbers in there, you can go and plug those into the calculator as well. Alright, so here's a couple of harder problems here. Solve for x when we have log of x is 2.1 or natural log of 5x equals 9. So we'll do both of these separately. The log of x is 2.1. First thing I'm going to do is take each side as an exponent of a base 10. And I choose base 10 because my log is base 10. And remember, 10 to the log base x is just going to be x. So this side over here is going to simplify to my variable, and that's what I want to happen. So we take each side as a power of this base that I used to have for my log. So 10 to the log x and 10 to the 2.1. And so then we just have x on the left side. 10 to the log of x is x. And 10 to the 2.1, I can either leave it like that or I can get a decimal value that's equivalent. So 10 to the 2.1, let's take a look at that. So that's going to be 10 to the 2.1. Should be the same there, 125.8925. So that does come out the same. Other side here, natural log of 5x equals 9. We're going to do the same sort of thing. Try to get rid of the natural log there by taking both sides as an exponent on that base e. Alright, so if both sides are an exponent of base e, e to the natural log of anything is just that stuff inside the log. So that's just going to reduce to 5x on that side. And then we are left with the e to the 9th on the other side. Alright, so 5x is e to the 9th. So anytime I look at these, I look at the base of my log and then use these as exponents when I'm changing those. And you'll notice this, if I change this log to exponential form, that is this equation right there. So some people prefer to write this intermediate step down. Some people prefer to go straight from this first one to the second one because it's just changing it to exponential form. I'll leave that up to you. The next step, we just divide both sides by 5. So dividing by 5, 5x over 5 is x. And on the other side, e to the 9th is 5. Or, sorry, we get e to the 9th divided by 5. Again, you could plug that into your calculator. It's about 16.20. So we won't do it for that one. But there's my final answer. Either the exact value, e to the 9th over 5, or the approximation, 1620.6168. So that's it for those. This one's slightly more complicated because I have more stuff inside my log. So the more you get inside your log, the more steps you have to do after you change the form. But I'm going to start the same way. I have log of something equals another number. That's always what we want to try to get things into if we don't have it already. So we're starting with single log equals a number. That means I can just take this base, in this case it's a base 10, and raise it to each side here. So we'll get 10 to the log of 3x minus 2 on the left side, 10 to the negative 0.8 on the right side. After that, 10 to the log base 10 is just the stuff inside. So now we're going to get 3x minus 2 is that 10 to the negative 0.8. Alright, and now I just solve for x. So try to get the x by itself. So that means I have to add 2 to both sides. So now we get the 3x is 10 to the negative 0.8 plus 2. I just leave that as it is. I'll calculate that in a second. And then the next step, divide both sides by 3. So that 10 to the negative 8 plus 2 now gets divided by 3, and it should come out to about 0.7195. So let's check that value real quick. So if I have 10, 10 to a power, there is this second 10 to a power button if you want. So let me clear these. So second, 10 to a power, this time it's negative 0.8. You can just use the regular stuff on there if you like. So 10 to the negative, let me go back, that should be a 0.8 on there. And plus 2, so plus 2. Alright, so I got 10, what is that? I don't know what that is. Clear. Alright, so let's try that again. So 10 to the negative 0.8. I think I was trying to type on my keyboard. It didn't work. So 10 to the negative 0.8. Close that exponent off. And then we'll add 2. Alright. See what that gives us. And then all of that is going to be divided by 3. So now I divide by 3. And I get 0.7195 if I round off to 4 decimal places. So that's our answer. Okay, so you can leave it in exact form or decimals. Most people like to put the decimal form just because it's easy to see what sort of number that does give us. Alright, here's our last type of problem. So here's some information that we're going to have before we actually solve the problem. This is continuous interest. So we have A is P times e to the RT. A is the amount that you get at the end of your compounding. So this would be continuous compounding. So instead of compounding interest monthly or quarterly, as banks usually do, this is continually. So not every month, not every day, not every hour, every second, but just continuously. Alright, so A is the amount that I get at the end of my time period. P is the principal, that's the starting amount. That's why they use the letter P. R is used as the interest rate for these, so that's the percentage rate. But we do need that as a decimal. Okay, so if I have 6% or 5% interest, I'm going to want to convert that to a decimal. And then T, this is always years, the number of years that I've been compounding. Alright, so let's go ahead and look at a problem and see how this works. So find the amount of money owed at the end of 3 years if a $4,000 debt is compounded continuously at 5% interest. Alright, so finding all our information, here's our A equals P e to the RT. And what I'm going to do is find all those values that I know. So I know the P is 4,000. Okay, we start with a $4,000 debt. The R is 0.05, so that 5%, I move the decimal place over twice, and I get 0.05. And then the 3 stands for the amount of time that I compound. So that's the number of years, and that goes in for T. Right, so we have the P, the R, and the T, and now we can solve for this final amount just by plugging those in. Alright, so we got A is 4,000 times e to the 0.05 times 3. 0.05 times 3 is 0.15. Plug that into our calculator in a minute. But that should come out to 4647.34. So let's just check that real quick. So if we get 4,000, so again I'm going to type in 4,000 here, times, and then e to a power, so this is e to the 0.05 times 3. And you can enter it just like that. Just make sure it all appears in that exponent before you close it off. So now we'll close off the exponent and hit enter. And so there's the 4647, and round it off to the nearest cent since we're doing a money problem, 34 cents. So that's it. We will get into a little bit harder problems in the future in our next section, solving logs using some of those logarithm properties of trying to condense things down and things like that. But these are sort of your basic evaluating logs, solving for stuff inside a log, and interest problems.